Good morning. You are welcome to today's lecture. We are still discussing the Npce tutorials review. So today we look at BDT. We review the BDT questions 4. We'll take it off from there. As usual, we look at the questions, discuss the questions, and the profile, they get the appropriate, look at the options and choose the appropriate answer. The appropriate option. Remember yesterday, we did the BDT review questions 4. Because there was no time, we agreed that today we are going to look at the questions and get the answers and take it up from there. Alright, so without wasting time, we look at the BDT review questions 4. Excuse me. So question one says, in weighing or measuring pharmaceutical ingredients where losses are unavoidable, a maximum error of dash is generally permissible. A. 1%, B. 2%, C. 4%, D. 5%. Alright, in every measurement, there is no measurement that is 100% accurate. So, what matters is what is the limit of error that is acceptable. Permissible error, acceptable error. That's why you see something like plus or minus in a measured quantity, because it is assumed that not just an assumption, it is a reality that there is no way you can measure anything 100% accuracy. There must be some level of errors, but this error, some level is permissible, while a particular level is not permissible. So the one that is maximum measurement, the maximum error permissible is 5%. 5%. So that means it should not be more than 5%. And it should not be less than 5%. So the correct option is option D. Mark. Alright, the second question says, doxycycline is available as a powder for reconstitution. After reconstitution, the concentration is 25 mg per 5 ml, and the total volume is 60 ml. The volume of the powder occupies 12.4 ml. The pediatric dose of doxycycline is 2.2 mg per kilogram. So you use this statement to answer questions 2, question 2, question 3, question 4, 5, and 6. So question 2 to 6. Alright, so let's start from question 2. Question 2 says, what volume of water should be added to achieve the appropriate final concentration? From the question, we are told that the entire volume of the preparation is 60 ml. But the powder itself occupied a volume of 12.4 ml. That is the doxycycline powder occupies a volume of 12.4 ml. So the question is now, what is the volume of water that should be added to achieve the final concentration. It's simple. This question would have taken us to direct to specific volume where we understand, where we know, where we explain the issue of the particular volume that will be displaced by that particular substance. But this is the case now. They have already told us, I mean, they mentioned gram, the weight of the cycling that will be that occupy that particular distance. Then we will now start going to specific volume for the weight. But this one now, they have already told us the volume occupied the what by the recycling. So all we need to do is this is Bdt. So we know that the final concentration the final volume is 60 ml. So if the final volume is 60 ml of the entire preparation, we constituted docycling. And the docycling part occupied 12.4 ml. So the volume of water itself will now be 60 ml minus 12.4 ml, which is 47.6 ml. 47.6 ml. So for 7.6 ml, in the volume that will be occupied by the volume of water that should be added to achieve the final concentration. So we have option A 12.4 ml, option B 37.6 ml, option C 47.6 ml, option B 60 ml. So the answer is option C 47.6 ml. Question number 3. So still based on this same question, question 3 says a physician orders 100 mg BID times 7 days for an adult, full stop. How many teaspoons will be given for each dose? How many teaspoons will be given for each dose? Option A 2, B 3, C 4, D 5. A physician orders 100 mg BID for 7 days, by 7 days for an adult. So the prescription by the physician from the question, let me get the question again. The prescription by the physician says doxycycline, right? Let me know about myself, right? Let me just go straight. 100 mg BID times 7 days. BID times what? 7 days. Now, the question now says how many teaspoons will be given in each dose. Now, a dose, this is 100 mg of doxycycline twice daily, that is every 12 hours for 7 days. So this question now say that how many ml will be given per dose. Now, a dose of the doxycycline is 100 mg because 100 mg will be taken twice daily. So if 100 mg is taken twice daily, that is a dose of it is what? 100 mg. Now, from the question, from the statement before, said that when after the constituted, the concentration is 25 mg per what? 5 ml. That means 5 ml. Yes, that's what it is. That is 5 ml of the entire preparation. It contains 25 mg of what? Doxycycline. So if you can see, break this down. This 5 divided into 5, we have that 5 mg will be contained in what? 1 ml. So each 5 mg is contained in 1 ml. That means 1 ml of preparation contains 5 mg of what? Doxycycline. But we are told that a dose of the doxycycline for this question is 100 from this prescription is 100 mg. So 1 dose of doxycycline is what? 100 mg. So if 1 dose of doxycycline is 100 mg, now we now use this 100 mg now because of say that we should find how many teaspoons that will be in 1 dose in each dose. So if 1 dose is 100 mg and 5 mg is found in 1 ml, so we now use set proportion. We use 100 mg to set proportion with this. So if you have 5 mg is contained in 1 ml, 100 mg will now be contained in X. You don't know. So that implies that X is equal to, if you cross multiply, we have 100 milligram times 1 ml over what? 5 milligram. Milligram cancel milligram. 5 divided 100, we have 20. So 20 times 1 ml, we have 20 ml. So 20 ml. So a dose of this doxycycline, a dose of it is 20 ml. Will be found in 20 ml. But we ask to find it in teaspoon. 1 teaspoon, 1 TSP is equal to 5 ml. So if 1 teaspoon is 5 ml, how many teaspoons, call it X, will be what? 20 ml. So if you multiply, we have that X is now equal to what? 1 teaspoon times 20 ml over 5 ml. Ml cancel ml. 5 divided 4, 20 is 4. 4 times 1 teaspoon, we have what? 4 teaspoons. So there are, so from the question, from what we can get here now, that 4 teaspoons will deliver what? A dose of the what? Doxycycline. So let's look at the option. Option A says 2. Option B says 3. Option C says 4. Option D says 5. So the answer is C. C is 4 teaspoons. So the answer is what? C. 4 teaspoons. Alright, so now that's for question number 3. Now let's look at question number 4. Let me clean the board. Let's look at question number 4. Question number 4 says, using the prescription in the question above, will the 60 ml bottle last for the entire treatment course? Option A, yes. Option B, no. So the entire volume is 60 ml. So they want to know that the prescription it says 100 milligram BID times 7. So you can simply say 100 milligram BID times 1/52. That is for 7 days. So if you calculate everything now, you find out that how many milligrams, to solve this question, we should find first of all how many milligrams will serve for 1 day. We know that 100 milligrams is for a dose, and we take it twice a day. So for twice a day, 200 milligrams will now be for a day, which is 100 milligrams times 2, twice a day, which means 200 milligrams for a day, times 7 days, times 7. So we have the total of what? 100 milligrams times 2, 200 milligrams times 7, 1,400 milligrams. That is if you want to find it using milligram. But if you don't want to find it using milligram, to do it straightforward, because we have already established that the dose is 20 ml, remember? So we can simply say 20 ml times 2 times 7, which is what? 20 ml times 2 is 40 ml. 40 ml times 7. 40 ml times 7 is 4 times 7. 4 times 7 is 4 times 7 is 20. 4 times 7 is 28. 28 another 0. 280. 280 ml. A dose is 20 ml because we established that a dose is 20 ml. So 20 ml times 2 is 40 ml times 7 is 280 ml. So for the entire, what it says for what? 1 week, right? It says for 1 week. So for the entire week is 280 ml. So because now say that well, you want us to check if the 60 ml bottle can last for the entire treatment course. No, we cannot. Because the entire treatment course is 7 days. And you take 20 ml 2 times daily. 20 ml 2 times daily. And the 2 times daily 40 ml times 7 is 280 ml. But what you would need to find out the one bottle is 60 ml. So it will not be what? Enough. So it cannot last. So the answer is B, no. The answer is what? B, no. You can also take it here. This is 1,400 milligrams for the entire 7 days. And we have that 5 ml contains 25 milligrams, which is 1 ml contains what? 5 milligrams. So if 1 ml contains 1 milligram, 1,400 milligrams should contain how many ml? Should be in how many ml? So X is now equal to what? 1,400 milligrams times 1 over what? 500 milligrams per milligram. If you divide this, 5 divided 14 is 2, remainder 4. You multiply by the remainder 4 times 10, 40, plus divided by 5 is what? 8. Bring down the 0, so it's 280 ml. So it's correct. So it cannot last for the entire treatment. So the answer is what? B. Alright, so let's look at the fifth question. Let's look at the fifth question. Question number 5 says, what is the dose of doxycycline for a 15-pound patient? What is the dose of doxycycline for a 15-pound patient? Alright, so let's solve it. What's the dose of the doxycycline for a 15-pound patient? Option A says 5 milligrams. Option B says 15 milligrams. C says 1.3 milligrams. D says 72.6 milligrams. Okay. So the question may be 15 pounds. So the patient weight is 15 what? Pound. The patient weight is what? 15 pounds. So if the patient weight is 15 pounds, the question now saying what is the dose for what? 15 pound patient. Remember from the statement we are told that the doxycycline should be delivered to the patient. And we have 2.2 for the question. We have 2.2 milligram per kilogram. 2.2 milligram per what? Per what? Kilogram. 2.2 milligram per kilogram. So what it means is that per kilogram weight of the patient requires 2.2 milligram. So that means we need to convert this to kilogram. This weight from pound, we need to convert it first to kilogram before we can do anything. So let's do the conversion. There's a conversion factor that says that 1 kilogram is equal to 2.2 pounds. 1 kilogram is equal to what? 2.2 pounds. So, excuse me. So, if one kilogram is 2.2 pounds, How many kilograms will be 15 pounds? So we don't know, we call it X. We bring 15 pounds here. We cross multiply. So X now becomes 1 kilogram times 15 pounds all over what? 2.2 pounds. Pound cancel pound. So we have 15 over 2.2 kilograms. So this 15 pound is equivalent to 15 over 2.2 kilograms. Now, for the question says, but we are asked to find it in dose. Dose, right? Remember, the say how many, what is the dose of the cycling for 2.2 pounds per patient? We'll move this weight to what? Dose. Remember from the question, we are told that we are giving the dose is 100 milligrams, right? One dose is what? 100 milligrams, but we will not work on it because we can't work with this. Is that clear? So we must work with this conversion factor. So we are already converted to milligram, we must work with this particular dose. So what we want to do is this: since the weight of the patient is 15 pounds divided by 2.2 kilograms, what that implies is that 1 kilogram from here now, 1 kilogram weight will require 2.2 milligrams of the doxycycline. Therefore, the weight of 15 over 2.2 kilograms will now require what? X, you don't know. So X is now equal to the cross multiply again. X is now equal to what? 2.2 milligrams times 15 over 2.2 kilograms. All divided by what? 1 kilogram. Kilogram will cancel kilogram. 2.2 will cancel 2.2. So we have 15 times 1 milligram, which will give us what? 15 milligrams. So a patient that has a weight of 15 pounds will need 15 milligrams of what? Doxycycline. This is as milligram. But the question says how many? It says what is the dose? What is the dose of the cycling for 15 pounds? Okay. The dose is 50 milligrams because all the options are in milligram. All the options are in 1 milligram. So no need trying to convert it again because we are going to be restricted on the option. Option A says 5 milligrams. Option B says 50 milligrams. Option C says 31.3 milligrams. Option D says 72.6 milligrams. So because there is no BJ and we are limited to milligrams, so we stop here. No need trying to move it again to dose. Is that clear? Yes. So the answer is what? 15 milligrams, which is option what? Option D. So number 5 is B. Hope you are still marking. Alright. So let's look at the next question. Question number 6. Question number 6 says, still on the same statement, says what is the volume of the dose of doxycycline for 15-pound patient? What is the volume of the dose of doxycycline for a 15-pound patient? Option A says 3 ml. Option B says 5 ml. C says 12 ml. D says 15 ml. Alright, so let's solve it. Well, we have already established that the dose is 50 milligrams. So we are not going to repeat this one again. We have already established that a dose, that one dose is what? 15 milligrams. That one dose is 15 milligrams. That's what we have already established. That one dose is 15 milligrams. So if we have already established that one dose is 15 milligrams, we are asked to find the volume of the dose. So remember from the question That's 25 milligram is contained in what? 5 ml. Which is said as saying, which is going to divide both sides by 5. We have 5 milligram is found inside what? 1 ml. So this 5 milligram is contained in what? 1 ml. How many ml will contain 15 milligram? We don't know, we call it what? X. 5 milligram is in 1 ml. 15 milligram will be X. So that means that X is now equal to what? We cross multiply 15 milligram times 1 ml all over what? 5 milligram. Milligram will cancel milligram. 5 divided 15 is 3. 3 times 1 ml is what? 3 ml. So the dose of the cycling will contain in what? 3 ml. So the option A says 3 ml, B says 5 ml, C says 12 ml, D says 15 ml. So the answer is option A, 3 ml. The answer is option A, 3 ml. Alright. So let's look at the next question. Okay, we are done with the question that has to do with the statements. Okay, so we're moving to the next section of this. We're moving to the next section of this work. We move down to question number 7. So no one is sitting down. Let me now stand up and work on this. Because I think it also has to do with calculation too. So let's look at question number 7. The question says, you have a prescription written as ampicillin 0.5 gram PO TID times 7 days. Let me write it out. Ampicillin 0.5 gram PO TID times 7 days. That is the prescription. Ampicillin 0.5 gram PO TID times 7 days. This means per oral TID 3 times a day for 7 days. 0.5 gram, which is the same as saying half of 1 gram, which is 500 milligram ampicillin. That's the prescription. So the question now says you only have ampicillin 250 milligram capsule in stock, full stock. How many 250 milligram capsules should you dispense? Option A, 24. Option B, 42. Option C, 84. Option D, 168. So let's look at the question, please. This question also wants us to understand the difference between a dose and the strength. Dose and the strength. Please, a dose of a drug from the prescription a doctor gives. Like now, look at prescription from the doctor now. The dose is that amount that a patient needs to be able to achieve a particular therapeutic outcome. That is the dose. So you can see, ampicillin 0.5 gram is the dose a patient needs 3 times a day. That is 8 hours to be able for 7 days to be able to achieve a particular therapeutic outcome. Attacking the bacteria. That's the dose. That's what we mean by dose. But when it comes to strength, the strength now is the amount of concentration of what you have in stock in your shelf. That one you have in your shelf that you now dispense, the amount you have in your shelf that you now use to, as the manufacturers package it. Like now, you may have a strength dose for a prescription. This says 500 milligram. But the one you have in your shelf, the capsule or suspension or whatever you have in your shelf may be a tablet or capsule that contain 250 milligrams. That one is the strength, is of what you have, is not the dose. So if you now want to deliver these dose, if what you have is capsule 250 milligrams, that means you need 2 capsules, which will now be 500 milligrams to be able to deliver this 0.5 gram or 500 milligrams. Are we now seeing the difference between the strength and the dose? Alright, so let's continue. So the dose is 0.5 milligram to be taken 3 times a day, as prescribed by what? The physician. But the strength is what you have on your shelf. Is what you have on your shelf. So the capsule, from the question, we are told that the capsule available on the shelf is Npce 250 milligram capsule. That is the capsule amount in the capsule. That is the strength of what is available. But the dose is this 0.5 milligram according to what the prescription. Remember that 0.5 milligram is set as saying 500 milligram. Because 0.5 is half of gram, and 1 gram is 1000 milligrams. So half of it is 500 milligrams. So this is the concentration of the ampicillin prescribed by the physician. Now, because it says you only have ampicillin 250 milligram capsule in stock. So in the shelf of the pharmacy, we have ampicillin capsule 250 milligram. That is what they have in shelf in that pharmacy. But the question now says, how many of this capsule is needed, should be dispensed to be able to take care of these 7 days? It's simple. Since you know that a dose is 500 milligram, and this 500 milligram will be taken 3 times daily, 8 hours for 7 days. But what you have in the shelf is 250, 1 capsule is 250 milligram. That means to deliver this 500 milligram, you need 2 of such what? Capsule. So the 2 capsules of 250 milligram is what is needed to deliver the what? 500 milligram. So for the entire duration, this is for a dose. A dose will need 2 capsules. But it's 3 times daily, so times 3. For 7 days, times 7. So 2 capsules times 3 is what? 6 capsules. For 7 days is what? 42 capsules. So 42 capsules is what is the pharmacist or pharmacy technician will dispense to be able to cater for this prescription for 7 days. So the answer is what? 42 capsules. Let's look at the options. Option A says 24. Option B says 42. Option C says 84. Option D says 168. So the answer is B, 42. Hope you have the questions, right? Yeah. I'm just reviewing the question. We are just done with question 7. So we are going to question 8. So let's look at question 8. This question 8, as a formula in this question 8, I'll write it down. So let me play. I'll do this now. Okay, actually. Okay. If there's any question, feel free to ask. Okay? Alright. Okay. Question 8 says a modified rain gas irrigation has the following formula. A modified rain gas irrigation has the following formula. Sodium chloride is 8.6 gram potassium chloride, potassium chloride is 0.3 gram. Calcium chloride is 0.33 gram. PEG, polyethylene glycol 3350 is 60 gram. Then water for injection, add 1000 ml. Now continue. Assuming that 980 ml of water is used in preparing the irrigation, calculate the specific gravity. So we are told that assuming that 980 ml of water is used to prepare this irrigation. So the water, assuming you know that 980 ml was used, we are told to do what? Calculate specific gravity. Specific gravity is what we are going to calculate. Are we together? Okay, so now let's solve. Option A says 1.05. Option B says, option A says 1.05. Option B says 1.06. Option C says 1.04. Option D says 1.043. 1.043. Please look up. Let's solve this question now. We are given this formula for modified rain gas irrigation. These are the constituents and these are their amounts. This water for injection was used as a variable for the question. And means that they mix this thing and use water to make it up to 1000 ml. That's what it is. So the entire volume of this irrigation, final preparation is 1000 ml. But we can, if you look at this thing now, we can never get the exact amount of water that was added because this formed a solution. In that solution, you cannot determine the amount of water added. So that's why they now say, assuming 980 ml of water was used. Assuming. Is that clear? Because if you add all these things, tell me how are you going to subtract gram from male? It cannot work. True or false? The entire volume is 100 ml. How will you subtract gram? Because this, if you add these things together, is a gram. The one that is remaining is water. So if you cannot do 1000 ml minus this gram, cannot work. So that's why they now say assuming that 980 ml of water was used, we will still go there. Now this will take us to what is called specific gravity. If you don't know what specific gravity means, you cannot solve this question. Is that clear? So the question now is what is specific gravity? Specific gravity is defined as the weight of a substance, as the ratio of weight of a substance to the weight of equal volume of water. Specific gravity is defined as the ratio of the weight of a substance to the weight of equal volume of water. See what I mean? Mathematically, specific gravity is what? Weight of substance over what? Weight of what? Equal volume of what? Water. So, specific gravity of a substance. The substance in question can be solid, it can be liquid, it can be gas. Is that clear? Now, if the substance in question is a solid or a liquid, the standard we use is water. You see something like weight of substance with the weight of equal volume of water. But if the substance is a gas, the standard we use is hydrogen. If the substance is a gas, the standard we use to use this comparison is hydrogen. You hear something like weight of substance with a weight of equal volume of hydrogen. That is, if the substance is a what? Is a gas.
Yes.
But from this formula now, the substance you are preparing is a liquid. True of us. Because once you add water of, all these are solid. Once you mix them and dissolve in water for injection, everything will become what? Liquid. So this substance is a liquid. That's why I'm using water. Is that clear? And that's why they use water. So now, if the specific gravity of a substance is weight of the substance over weight of equal volume of water. Now, another place now you have a kind of confusion is what is the meaning of weight of equal volume of water? That's where the big question lies. If you understand this denominator, weight of equal volume of water, you are good to go. Now, what do you mean by weight of equal volume of water? Now, weight of equal volume of water is talking about the weight of water that has the same volume with that substance. Let's assume the volume of that substance is 20 ml. Is that clear? Good. Let's assume that the volume of that substance is 20 ml. Then, if you want to get weight of equal volume of water, this is for the substance. What you do is this: measure the same 20 ml of water. Okay? This is the volume of the what? Substance. Okay? You measure the same volume of water, 20 ml of water, and weigh it. The weight this 20 ml of water will give you is what you put here. Is it clear? So weight of equal volume of water. The weight, this 20, that is weight of water that has the same volume. That substance is weight of equal volume of water. Is it clear? Good. So if you understand this, specific gravity is very easy to solve. Now let us now go back to the question. From the question now, this is the entire substance now. What is it if you want to check the weight of that substance? If you check now, everything here is a male because it's liquid. How do we now check the weight of that substance we are preparing? This is how to do it. We know that everything is what? In 1,000 male. But we want to check the what? You can silence it, please. Let's continue. So, what do we now do? We are told that the volume of water added is what? 918 ml, right? Good. So, to get the entire, we put 918 ml there. So, if you see what this weight will look like now, you have put down this thing and get formula. Can I get it? Let me see how the entire formula will now look like. See now, let me now rephrase the entire formula now. Because we are told to assume that the volume of water for injection is what? 918. So we put R. It's no longer R now. R disappeared. Because you are no longer making up. The volume of water is what? 918, right? Right? The entire volume will become what? What I am saying. But we cannot get the weight of the substance if we are working in volume, male. So how do we get the weight of the substance? We clean this and convert this male 918 to gram. and then add up. Is a standard. It has been established as a standard. There are other different calculations and different conditions that was considered, and it was agreed that for water alone, water, not all liquid, water alone, that 1 ml is settled with what? 1 gram. For water, 1 ml of water is settled as 1 gram of water. For water alone. For what? Water. So, because this is water now, that means 980 ml is settled as same what? If 1 ml of water is settled as 1 gram, so 980 ml of water is settled as what? No, if 1 ml of water is settled as 1 gram of water, so 980 ml of water is settled as what?
980 milligram.
Gram, not milligram.
Yeah,
because 1 ml is 1 gram. 980 what? Gram. So we have succeeded in converting the volume of water for injection to what? 980 gram. So we now calculate the entire volume, the entire weight of the rain gas lactates, rain gas irrigation. Add it up. What's the answer? Everything is what? 8.6 plus 0.3. You add this.
Yes.
Add 982 because we add everything.
1,049.23.
049 what?
0.23.
Point what?
23.
Gram.
Yes, sir.
Is that clear?
Yes, sir.
This is the weight of the entire lactates, entire rain gas irrigation. This is the weight of that rain gas irrigation.
Yes, sir.
We have remember that specific gravity is weight of substance over weight of equal volume of water. We have determined the weight of the substance, which is what? 1,049.23 what? Gram, right? Now, let us now find weight of equal volume of water. Remember from the formula that the entire volume of this rain gas irrigation is how many mil?
1,000.
1,000 mil, right? So, the volume, this is the weight, right, of the irrigation. Weight of what? Is what? This, right? But the volume of the irrigation is what? Is what? 1,000 watts. Mil. Is it clear?
Yes.
So volume of the entire irrigation is 1,000 mil. Now, remember, we want to calculate weight of water that has the same volume as 1,000 mil. Is that clear? Is that clear?
Yes, sir.
So if volume of the irrigation is 1,000 mil, that means volume of water is what? The same 1,000 mil, right? Right? Good. Weight of equal volume of water. So if volume of the irrigation is 1,000 mil, therefore volume of water is 1,000 mil. So they have the same volume. But we want to convert the question is we want to check the weight of water that has the same volume as 1,000 mil. That means we convert this 1,000 mil to weight. Remember that for water, 1 gram is equal to what? 1 mil for water.
Yes.
So let's convert this 1,000 mil to gram. What will it give us? It's simple. Now, if 1 gram is 1 mil,
Yes.
1,000 mil is how many gram?
1,000 gram.
Good. 1,000 what? Gram. So the The weight of equal volume of water is 1,000 grams. What it means is that 1,000 grams of water has the same volume with Ringer's irrigation. So the weight of equal volume of water is 1,000 grams. So we have determined weight of the substance, and we also determine weight of equal volume of water. Let us now put it back to the formula for specific gravity. Can I click?
Yes, sir.
So let's put it back to the formula for specific gravity. So remember the formula? Specific gravity is equal to what? Weight of what?
Substance.
Sorry, this thing is specific gravity is what?
Weight of substance.
Weight of what?
Substance.
Substance over what?
Weight of equal.
Weight of equal volume of what?
Volume of water.
Water. From our question, from the all this we have been doing, weight of substance is what? 1,049 point what?
23.
Gram. Divided by weight of equal volume of water is what? 1,000 what? Gram. So divide, what's the answer? No, divide 1,049.23 divided by 1,000. You cannot give me 1,000 again.
Okay. 1,4.
You know, you cannot give me 1,4.
149.
You cannot give you cannot.
Divided by 1,000. Okay, 14 points.
You cannot give me that. What are you doing?
You said I should divide 1.
Divide 1,049.23 by 1. 1 what?
1.049.
Good. 1 point what? 04923. Is 1.04923. It's too long, we approximate. Look at the options. If you approximate now, you will give you what? 1.0 what? 5, right? Please, specific gravity has no units. Know that point. Specific gravity has no unit. Is that clear? Now, so look at the option. What's the answer?
D.
Check well, it can't be D. It's A, right? The answer is A. Because we approximate. 1.05. The answer is A. 1.05. There's also something I want to say about this specific gravity. Please, if the specific gravity of a substance like here now is above 1, what it means that the substance is heavier than water. Is that clear? Like now, as this is a liquid now, because it is above 1, it means that this substance, this Ringer's irrigation is heavier than water. So if the same thing with if the specific gravity is less than 1, it means that it's what? Lighter than water. Because specific gravity of water is taken as what? 1. Specific gravity of water is what? 1. So any substance, any of these that is whose specific gravity is above 1 is heavier than water. You know, there are some oil that if you put them together with water, they will float. Have you noticed that? What it means is that substance has specific gravity less than what? 1 is lighter than what? Water. The one that is heavier will be on the below, while the one that is lighter will be on top. Is that clear? So that is for question number what?
Number 8.
Question number 8. Any question here, please ask. If you have any question here, please ask. If you have any question here, please ask. Any question? Alright, so let's go to the next question. Let's go to the next question. Question number 9. The question says, how many millimeters of water must be added to 180 ml of 40% volume per volume solution in order to produce a 5% volume per volume solution? Option A, 1,250 ml, B, 1,240 ml, C, 1,260 ml, D, 1,200 ml. Okay. This question talks about dilution. Are we together?
Yes, sir.
This question talks about what? Dilution. If you watch, the initial concentration was 40% volume in volume. But when the water is added, it changed to what? 5% volume in volume, which means that it has been what? Diluted. The concentration has gone down. That means it has been what? Diluted. We are told that initially, the initial concentration of this solution was 40. So C1, right?
Yes.
Was what? 40% volume per volume, volume in volume. And the volume of that solution was what? V1 is equal to what? 180 ml, right?
Yes.
Now, but when water was added, everything changed. Is that clear? The concentration, which is C2, becomes what? 5% volume in what? Volume. Are you following? But we don't know this final volume it assumed. We are really giving the final volume it assumed. We are not giving the final volume it assumed. V2, we don't know. Please look at this question. This question is tricky. We were not asked to find the final volume. We were asked to find the volume of water added. So for us to find the volume of water added, we must find the final volume first. When we find the final volume, we subtract the initial volume from the final volume for us to get the volume of water added. Are we together? Now, so using the addition formula, C1 V1 is equal to what? C2 V2. We are looking for V2. So we make V2 the subject of the formula. This becomes V2 is equal to what? C1 V1 over what? C2. So from here now, we are giving C1 as what? 40% volume in volume times V1 is what? 180 ml over C2, which is what? 5 ml. Ml will cancel. Sorry, 5% what? Volume in what? Volume. Percent volume in volume will cancel percent volume in volume. So what's the answer? 5. You can let me fast, punch it fast. Let's not waste our time. Punch it so don't waste our time. 40 times 180 divided by 5. 1 what?
1,440.
So the final volume is what? V2. is 1,440 mil. Now look up. This is the initial concentration, right? And this is the initial volume. Here now, when water was added, this initial volume was 180 mil. Immediately water was added, the volume increased to what? 1,440 mil, right? It become more, but the concentration, because it's now what? Diluted. So the concentration now moved from 40% to what? 5%. So this is the final volume. We were not told the amount of volume of water added. So volume of water added is what? Subtract V1 from what? V2. You now know the volume of water, the actual volume of water that was added. So volume of water added is equal. Can I clean here? Please write. Option A says 1,250 mil. B says 1,240 mil. C says 1,260 mil. D says 1,200 mil. So that's the options. Are you done?
Yes.
Are you done?
Yes.
So now I can now change. So the volume of water added is simply volume of water added is what? The final volume, which is V2, minus what? The initial volume, which is V1. So final volume, as we calculated, is 1,440 mil minus initial volume, which was 180 mil, right? So what is the volume of water added? Subtract this. What's the answer? What type of marker is this one? Yeah? Marker is going inside. Yeah? So one what? 1,260. Good. So it's what? 1,260 mil. So the volume of water added is 1,260 mil. That should be option what? C. Option what? C. So the answer to question 9 is 1,260 mil. Option C. Alright, if you are good, let's go to the next question. Question 10. Question 10 says, let me clean. Can I clean? Huh? Okay.
Yes.
Okay. Okay, the question 10 says, from the following formula for gastric lavage, from the following formula for gastric lavage prior to colonoscopy, Calculate the quantity of sodium bicarbonate needed to prepare 100 liters of the formula. The formula states polyethylene glycol polyethylene glycol 3,350. Sorry. The formula says polyethylene glycol 3,350 16 ml. Sodium chloride sodium chloride 1.46 gram. Potassium chloride 0.745 gram. Sodium bicarbonate 1.68 gram. Sodium sulfate 5.68 gram. Water, QF, sufficient quantity. Make it up to 4 liters. Look at the formula. Look at the formula. This is the formula for the gastric lavage, right? For colonoscopy. They want us to calculate the amount of sodium bicarbonate needed to prepare 100 liters. So the major our concern is what? Sodium what? Bicarbonate. Is that clear? This question is talking about enlargement. The topic is about enlargement and reduction of what? Formula. Reduction and enlargement of what? Formula. You know whether it is compounding or formulation. There's a formula given maybe in the official book that contains the amount of ingredients you need for a particular volume quantity. Now, depending on the quantity you want to prepare, if you want to prepare thousands of bottles, you need to do what? Enlarge the what? Formula. Am I completing? To be able to produce thousands of bottles. Maybe for what you have in the formula, maybe in the official book, you want to prepare just small amount, less than what you have in the formula. What you're going to do is that you will do what? Reduce the what? Formula. Am I completing? Am I completing? Now, please, if you're not following, please ask question. You do what? You reduce the what? The formula. Now, look up here. Look up. From the formula, everything here, the entire volume from this thing now, once you see water, this QS means sufficient quantity. R means make it up to 4 liters. You don't need to be told that the water is the favorite here. That means the entire product is liquid form. Am I completing? And the amount of the entire product is 4 liters. Is that clear? So from the formula, sodium bicarbonate 1.68 gram is required to produce 4 liters. Polyethylene glycol 3,350 16 ml is required to produce 4 liters of this. Sodium chloride 1.46 gram is required to produce 4 liters of this. That's the meaning. Potassium chloride 0.745 gram is required to produce 4 liters. Sodium bicarbonate 1.68 gram is required to produce 4 liters. Sodium sulfate 5.68 gram is required to produce 4 liters, right? Good. So the amount, the question wants us to calculate the quantity of what? Sodium bicarbonate needed to prepare 100 liters. So let us not, remember this is OBJ. You have no business with the other ones. Focus on the one you are asked. Here now, sodium bicarbonate 1.68 gram is required to produce 4 liters. True of us. Now, if 1.68 gram of sodium bicarbonate is required to produce 4 liters of this product, how many gram of sodium bicarbonate will be required to produce 100 liters? Because we are asking amount required to produce what? 100 liters. It's simple, just go straight and solve. You know it's OBJ. If it is SM theory, you start doing proportion, finding for everything before you determine that of sodium. But this one is OBJ. Go straight to the point and get your answer and go your way. So don't waste your time. Are we together? So that's why I picked this sodium bicarbonate and I'm going straight. Can I clean? Can I clean? So from the question, from the formula, we have established that 1.68 for the formula 1.68 gram look up of sodium bicarbonate are required to produce what?
Okay, 2 liters.
Sorry, 4 liters not there. 4 what? It's 4 liters, right? 1.68 gram of sodium bicarbonate is required to produce 4 liters of the what? Lavage, right? Lavage, right? So, how many grams of sodium bicarbonate? We don't know. Sorry to us. S. Will be required to produce what? 100 liters. Is that clear? If 1.68 gram is required to produce 4 liters, how many grams is required to produce 100 liters? So we cross multiply. X is now equal to what? 1.68 gram times 100 liter over what? 4 liters. So let me write out the option set. Option A says 44 gram. Option B says 43 gram. Option C says 42 gram. Option D says 45 gram. Have you punched your calculator? What's the answer? Liter cancel liter. What's the answer?
42.
40 what? 42. So X is what? 42 gram. So 42 gram of sodium bicarbonate is required to produce 100 liters. Are we together? So what's the answer for the option? Option what? C. Option C is the answer. Is it clear? Any question here? Option C is the what? Answer. So this question talks about reduction and enlargement of what? Formulas. Reduction and enlargement of formulas. We solve questions on specific gravity. I believe that if you ask questions on specific gravity, you can solve it, having in mind the meaning of weight of equal volume of water. Is that clear? Alright, so we are moving to the next question. If you are good, let's go. We have also solved questions on dilution, right? So I think we can do that one. And we have also solved questions on dosology. Doses, right? Good. Alright, so now let's go to the next question. Question number 11. Question number 11. Are we good?
Yes.
Can I clear? Alright. Question number 11. of 11 says low dose aspirin. Low dose aspirin contains 1/4 grains of aspirin in each tablet. Low dose aspirin contains 1/4, so that means 1 tablet of the aspirin, low dose aspirin. Of course, you know what low dose aspirin is now, right? Vasopressin. I talked about it yesterday when I talked about platelet aggregation, right? That is stop platelet aggregation. That's why it's recommended for those that are 40 that are good for the heart. Is that clear? So now we are solving question now on it now, calculation. Now one tab of that low dose aspirin contains 1/4 what? Grains. Grain is a unit of measurement for weights. For weights in common or imperial system of what? Measurement. You see here, avoirdupois and apothecaries. Is that clear? Avoirdupois and apothecary. We have apothecary grain and avoirdupois pound grain. All those things. They are just. This is just weights, but in old system. Now, from the question, 1 tablet contain 1/4 grain of what? Aspirin, okay? Good. So let's continue. Low dose aspirin contains 1/4 grains of aspirin in each tablet. Full stop. How many tablets can be prepared from 1 avoirdupois pound of aspirin? How many tablets can be prepared from 1 avoirdupois pound of aspirin? Please, for us to solve this question, you should be able to know what is the meaning of the relationship between avoirdupois pounds and grains and apothecary. Avoirdupois pound and apothecary pounds are not the same thing, even though there's a link. Grain is the link for 2 of them. So 1 avoirdupois pound is 7,000 grains. Please note this down. 1 avoirdupois pound. 1 avoirdupois pound is 7,000 grains. While 1 apothecary pound is 5,760 grains. They are specific here. They say avoirdupois pound. So we are working with avoirdupois pound, not apothecary pound. So let's work with avoirdupois pound. The question says how many tablets can be prepared from 1 avoirdupois pound. So 1 avoirdupois pound is 7,000 grains. We are good to go. Are we together? Are we together? It says 1 avoirdupois pound. So no wasting our time. We just substitute 1 avoirdupois pound with what? 7,000 grains here, right? Right? 7,000 what? Grain. So, can I clean here? So, if one tablet contains 1/4 grains of aspirin, so how many tablets will contain 7,000 grains of what? That's what we want us to find. So how many tablets? So we make this x the subject of the formula. X is now equal to, if you cross multiply, you have 1 tablet times 7,000 grains over what? 1/4 grain. This 1/4 is the same as saying 1 times 4 is 4 plus 1, 5. So let me just say 5 over what? 5 over what? 4 grains, right? So we are good to go. Grain cancel what? Grain. We are left with what? Tablets, because we are looking for tablets. Remember the laws of fraction. To divide, this one come up. So we have something like this. 1 tablet times 7,000 what? Grain times what? 4 over what? 5. We are good to go. 5 divided 7,000 is what? 5 divided 7, this is 1. 1, remember 2. 24. 1,000 what? 400. Are we good to go?
Yes, sir.
So we multiply out. This will give us 5,000. 4 times 2 is 28. 28 times 2 is 5,600 what? Tablets. Are we good to go? So that means 5,000. So what we need to produce 5,600 tablets, and each tablet will contain 1/4 grain of aspirin is 7,000 grains. So the answer is 5,600 grains. And tablets. So we have option. Option A is what? 5,600 tablets. Option B is 4,600 tablets. Option C is 3,006. Option D is 2,006. So the answer is option A, 5,600 tablets. So the answer to question 11 is A. Any question here? Please ask question if you are confused in any step I took in solving the question. I will explain. Any question? Any question? No question. So this question is a combination of posology. It's a combination of posology, measurement systems of measurement, both and the apothecary, mainly old system. Is that clear? So that's what where this question came from. So shall we move to the next question? All right. Shall we? Huh?
Yes, sir.
All right. So. All right, question 12. Question 12 says sodium chloride is a 2-ion electrolyte. Sodium chloride is a 2-ion electrolyte dissociating 90% in a certain concentration. Full stop. Calculate the freezing point of a molar solution of sodium chloride. Option A. Option A says 3.53 degrees Celsius. Option B says minus 3.53 degrees Celsius. Option C says 1.73 degrees Celsius. Option D says minus 1.73 degrees Celsius. Question says calculate that sodium chloride is a 2-ion electrolyte dissociating 90% in a certain concentration. Calculate the freezing point with molar solution of sodium chloride. So this question has to do with the isotonic solutions, combining the dissociation, I factor, the freezing point depression, cryoscopic constants, molality, not molarity now, molality. So this simple question cut across a lot of things. So I want us to listen carefully while we solve the question. Because if you don't know the type of question they will bring out That is, if they set question on isolated solution. So please, I want us to listen carefully while we solve this question. Alright, so now, before we can solve the question, I will write out the formula for freezing point. Is that clear? Are we together?
Yes,
Is equal to I factor times the cryoscopic constant and what? Molality. Molality is the formula we need to solve this question. Molality. Molality. This is a very vast topic, but I'll just pick the one that concerns the question. Is that clear? Question that has to do with isolated solution is very vast. There are a lot of, because there are a lot of colligating properties you put into consideration. There are many of them. We have freezing point depression, boiling point elevation, osmotic pressure. There are a lot of them, but the one that concerns this topic is what? Freezing point or depression or freezing point. Now, but by the end of this thing, now we explain what we mean by freezing point depression and freezing point. And I've said, so question may ask you freezing point. Stop here. So may ask you what is the freezing point depression. Now, let's begin. The first thing I'll find is I'll look at this, what is it called? I factor. Am I communicating? Now, if you get water on this spoon, I want us to listen, please. Water on this spoon has a freezing point of what? 0, right? That's water. But if you dissolve, if you get sodium chloride or any solute and dissolve it in water and form a solution, the freezing point will not be the same. The freezing point of the entire solution, that solution will form will be lower than the freezing point of what? Water. Am I correct? Get water, the freezing point is 0. But once there is anything, call it impurity or any solute that will dissolve inside it, any solute, using sodium chloride as an example, if you dissolve sodium chloride and check the freezing point, or it is now a solution now, no longer a solvent, and check the freezing point of that solution formed, it will be less than 0. Am I correct? Now, so the freezing point, the new freezing point, is the freezing point of the solution. It will give you negative value. That's why you see this and this are the same thing, but this one is a negative value. This are the same thing, right? But this is a negative value. The one that's a negative value is the freezing point itself. Am I correct? Because it's a negative value. But if you hear depression by freezing point depression will give you positive answer, because it is just you are just calculating by how is it depressed. It is depressed by social amount. Am I communicating? That's the question. First thing I want us to understand. So the difference between freezing point depression and freezing point, and why is it that when you form that solution, it will have a lower freezing point? It will become minor, because naturally freezing point of water alone is what? 0. Is that clear? Good. Now, without wasting time, so I don't go back again. Let me say one or two things about this. The cryoscopic constant. This one talks about what happens to. This one is you see to describe what happens to freezing point of a solvent when a solute is dissolving. Is that clear? Is that what happened to the pressure? How the freezing point is depressed when a solute is what? Dissolving. That's what this one is talking about. So solvent, water in a solvent, has its own what? Cryoscopic constant. Is that clear? That of water has its own cryoscopic constant. So let's continue. Now, let's look at this I factor. these solutes, when they dissolve, some of them form electrolytes. Some are non-electrolytes. What it means that if you dissolve a solute in the water, some solute will form a solution that is electrolytes, can conduct electricity, while some will form one that are non-electrolytes. Those ones that form electrolytes mean that they have ions. It's the ions is what conduct electricity in that liquid form. But the ones that are not non-electrolyte, they don't form ions. Something like boric acid. Boric acid in water is a non-electrolyte. Am I completing? Because the dissociation is almost insignificant. But that of what sodium chloride, it dissociates very well in water. Am I completing? It dissociates very well. So those non-electrolytes, their dissociation constant, this I factor, is almost 1. It's 1 because they don't dissociate. Is that clear? See what I mean? Let's assume that this is a non-electrolyte. Let's assume that this is this substance now. A. If you dissolve in water, it's a non-electrolyte. If you dissolve in water, it doesn't dissociate. It will form the number of particles. It form. There's no particles there. It is all dissociated. Everything here is still 100%. Okay? Before it dissolves, after it dissolves, there's no dissociation. It's still what? 100%. The I factor of this non-electrolyte is the number of particles after dissociation divided by the number of particles before anything. Making it what? 100% over what? Which is what? 1. Is that clear? For a non-electrolyte. Are we together? Can I clear? Good. Now, but what of electrolyte? Remember we are working with sodium chloride. The question is mentioned, because of mention, we have listed. Are you good? The question mentioned sodium chloride, right? Good. What of sodium chloride? For the question says, sodium chloride is a 2-ion electrolyte. There are some that will form 3 ions, right? Like zinc chloride now. Zinc chloride will form 3. 1, 2, 3. Are we together? But for sodium chloride, if it dissociates, it form only 2 ions because it dissociates. So, if sodium chloride come in contact with water, so I'm going to handwrite. If sodium chloride come in contact with water, so what will happen? It dissociates into what? Sodium ion plus what? Chloride ion. The question said that it has 90% dissociation. Initially, everything here was what? Nothing. Undissociated is 100%, right? But when it dissociates, it will form, they said it had 90% dissociation. So 90% is here. Are we together? And chloride is what? 90%. Is that clear? Now, the one remaining here after this whole thing is what? Undissociated is what? 10%. Right? Undissociated is 10%. Particles. Dissociated is 90%. Remember, all this exists in the same system, in the same solution. All this is now. These particles are in the same solution. That means for electrolytes, the concentration is to increase for electrolytes because more particles are liberated. Is that clear? Now, the entire particles here now that when we say particles, we are talking about the dissociated ones. Is that clear? Because it moved from molecule to what? Particles. Is that clear? The dissociated ones is now 90% plus 90% is what? 180%, right? Plus 10% is what? 190. So we have 190% particles that existed in that system. But this 190 came out after what? After what? Dissolution, right? And dissociation. But what was there before everything started? 100 what? Percent. So the I factor for this sodium chloride that dissociated for 90% is what? 190 divided by 100, which is what? 1 point what? 190 over 100 is what? That's what 1.9, right? Yes, it's 1.9. Right? So we have found our I factor, which is what? 1.9. So let's write it down. I is what? 1.9. So we find out this in one after the other after we now calculate and find our freezing point. Is that clear? Good. Can I clean? Okay, please, if you are not putting it down, you can put it down. Are we together? Good. Now, here, this now for water, is 1.86. That one is what? Straight up. Is that clear? Here is what? 1.86. But there are other things involved in this. Look up. Look up. 1.86, yes. 1.86. Any issue there? Do you have any contrary opinion? No, this one is established. It's fixed. It's fixed. Is that clear? It's fixed. For water, it's fixed on its own. It's fixed. Actually, most time, look up. Most time, it normally goes with like this box, because this I for a electrolyte, one time this will still give you this. Is that clear? But for electrolyte to consider this, that's what we solve for this. Is that clear? But just let's leave it at this for now. Now, this one is 1.86. Good. Now, molarity. I can clear here now. Yes. So let's talk about molarity. Remember I said that this topic is vast. I just pick the one that relates to the question. So we don't waste time. Molarity. Please, there is molarity versus molarity. There are the same thing. Molarity and molarity. This molarity is your normal concentration in load. But molarity talks about is simply the ratio of the 1 mole of a substance. 1 mole of substance in 1 kilogram of what? Solvent. Is that clear? 1 mole of a substance. 1 mole of substance in what? 1 kilogram of what? So a molar. If you hear something like a molar solution, what it means is that of a substance, 1 mole of the substance over 1 kilogram of the what? Solvent. Is that clear? So that means from the question, a molar solution of sodium chloride is 1 mole of sodium chloride. 1 kilogram of the what? Of water. That's the meaning of molar solution. Is that clear? I just want to explain it. I don't need it in solving this thing. Because they haven't told us 1 molar solution. So molarity here is what? 1. True of course. But I'm just trying to explain something here. Are we together? I'm just trying to explain something here. So in case you see tomorrow, because there are some questions you will see on another topic that will test your knowledge of this molarity. Okay? So with this now we can solve the question. So freezing point is now equal to what? 1.9 times what?
1.9 times 1.86 times 1.
What's the answer? What's the answer?
3.5.
3 point what? 3 point what?
534.
5.3. The option limit us to 2 decimal places. Let's limit our answer to 2 decimal places. 3.5 what? 3.5 degrees what? So the answer is what? A. Look up. I took time to explain this because I know that it's causing confusion and I ended up making that same mistake. Look up, please. The question says freezing point, not freezing point depression. But I think freezing point was depression. It's minus. Because the freezing point is now minus because it's less than what? 0. Is that clear?
Yes.
Is that clear? Please, let's notice. It's less than 0, so you should minus. You can know something and say that's what I'm feeling. Please, let's be careful. It's what? Minus. I think the question says, what's the freezing point depression? That's when you can put what? 3.5. But it says freezing point, so it's minus because it's less than 0, minus 3.53. Please. So now let's look at the other questions. Question 13. Question 13. Okay. Question 13 states all that you need to move a product from one point to another, such as transportation, warehousing, human resource, records, etc. is called A. Management, B. Stock keeping, C. Logistics, D. Administration. What's the answer? Logistics is the answer. Are we together? Yeah, because logistics is a full system of moving or storing goods. B. Stock keeping, what others like stock keeping, management, and so they are now just part of. Is that there? But the broad thing is what? The full system is what? Logistics. So the answer is what? C. Logistics. Question 14. Question 14 says any maintenance activity that is planned. Sorry, how many of you answered this question yesterday in class? Who were marking? Good. Any maintenance? Did you answer this question in the class yesterday? You were not there?
Which one, sir? Is it particular one? No, I wasn't in the class.
Okay. That means you're the only one here. Who you're marking because I will collect all those scores. Alright. Any maintenance activity that is planned, documented, and scheduled is called A, planned maintenance, B, planned preventive maintenance, C, unplanned maintenance, D, none of the above. What is the answer? B is what? Please let's look at it. Let's contribute, please. Here now, please contribution. Remember, I will have solved on the courses, so now we need to discuss now. At least we will discuss. Two of us. Yes. Oh yeah.
Okay, you're asking about this particular one.
Yes.
I was in class now. When you said
Hope you are marking.
Yes, I'm marking.
Is it in your market?
Yes.
Exchange. You can't mark your own. Exchange. I'm saying she mark. No, give to. She was there. You cannot be marking your own. Okay, so the question says any maintenance activity that is planned, documented and scheduled is called A, planned maintenance. A, planned maintenance, B, unplanned maintenance, C, planned preventive maintenance, and D, none of the above. Someone say planned preventive. So I want to know why you say planned preventive. No, if you look at it that way, maintenance is what you will still do. True of us. So by planning it, saying plan preventive, is more as is as good as you repeating yourself. But that plan alone is to prevent. So they don't need anything telling us plan preventive.
So that's why I say.
Yes. It's simply what plan what maintenance. Yes. Because that plan alone is to prevent
Something from.
because if you plan, then you cannot schedule your maintenance. So it's more of they are essentially plan maintenance. Alright, the next question says, hope you are marking A. 15 says the three main parts of LPO includes the following, with the exception of the three main parts of LPO include the following of an LPO, the following with the exception of A, LPO header, B, LPO body, C, LPO footer, D, LPO letterhead. What's the answer?
First thing, what's the
Local purchase order. So what's the answer? Where you are working, like pharmacy, the purchase order you prepared, local purchase order. So we are talking about the parts of it. So what's the answer? I'm waiting. Wait. I'm coming. Okay, what else? Sorry. What's going on here? Look at the questions now. It's simple to answer. those are some. What did you write?
Wait,
F15.
I think I picked
This was.
Npce Bdt.
Alright. We are talking about parts of an Npce, simple. Parts of an that or just part of it. Different parts. Npce letter is not a part, just what the paper you are using. So it's not a part of it. But the header is a part, the body, the footer is a part. So the answer is what? D. Npce letter head is not a part of it. So the answer is D. Please mark, 15 is D. 16 dash is a detailed statement of the contents of a package. Dash is a detailed statement of the contents of a package, indicating the net and gross weight, dimensions, shipper or consignment, description of goods, hazardous information, which is used by the recipient to verify the content of the package. A. Packing list. B. Packaging. C. Web bill. D. Requisition, issue, and receipt voucher. What's the answer? A is what?
Packing list.
Yes. Packing list. In fact, packing list tells you complete information about what is the content. Exactly every information you need. Web bill is just to acknowledge the transport. Web bill just acknowledge what is the transportation. Packaging is a process of putting everything together. Are we listening?
Yes, sir.
So, other ones are just for record purposes. The requisition, the voucher, all those are for record purposes. So, the answer is what? 16 is A. 17. The purpose of a logistic management information system. The purpose of a logistics management information system is to dash and dash information to other levels in the system in order to make decisions that govern the logistics system. A. Collect, organize, and report. B. Claim, validate, and report. C. Procure, distribute, and report. D. None of them. What the answer?
I think it's C.
A. Okay, I agree with you. A. I agree with you. You said all these are true about packing lists, except we said that the answer is B, right? It says each packing list should reference the shipment for which it is made. It's correct. This one you should reference it, because if not, it can cause confusion. This says that the line items totals should not agree with the relevant commercial invoice. This one is not. This one is not true. True of us. Yes, because they should agree. They should what? Agree. And this makes this be the answer, because the question says except. Then C says the packing list is only required when shipped goods are packed into larger units. It's true. Yes, this one is normal. That what makes it not to be the answer. This says packing list helps in identifying lost cargo, especially for carrier and insurance claims. Yes, it helps identify lost cargo if there's any, if such happens. So that's why option D is not the answer. The question says except. So the answer is what? B. Question 22. Poor logistics and supply chain management result in all of these except A. Expiries, B. Damages, C. Wastages, D. Customer satisfaction. What's the answer? D. Yes. If you are logistic and supply, if the logistic and supply chain is poor, the management is poor, it leads to a lot of expiries. It also leads to damages. It also leads to what? Waste. True of us. Damages combined with too much expired product is lead to what? To damages, right? But customer satisfaction is, in fact, poor logistics and supply chain management lead to poor customer what? Satisfaction. True of us. So that's why this is that, because they say except. So 22 is D. Please hope you are still marking. 23 says all the following are processes. All the following are processes of handling expired medicines, except A. Remove the expired or damaged products from the usable ones on the shelf. B. Put them in a carton and mark the carton expired boldly with red marker. C. Enter the quantity that expired on the stock card under loss and deduct the quantity from the original balance and write the new balance. D. Destroy the medicine by yourself by burning them. What does that say? C. 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 Say your own now. D is the answer now.
Okay, yes, D.
When your medicine expired, when your medicine expired, normal, you should remove it from
the shelf.
So that's why A is not the answer, because it's normal thing you do. B says put them in carton. Normal thing you put them in a separate carton, right, and mark them expired with a red pen. That's normal thing you do, and that's why B is not the answer. C says enter the quantity that is expired in the stock card under loss. Yes, we have card for loss. So they don't confuse you with what you have. You think that you say have stock, without even knowing that you don't have stock here. So you put it under loss. So that's normal thing you do. That's why C is not the answer. This says destroy the medicine. Please, you don't destroy by yourself, right? It's not that that will come and take care of that one. Are we together? So the answer is what? D. Number 24 says drug revolving fund system is a concept that does all the following except A. Promote access to drugs. B. Ensures availability of drugs. A. Promotes access to drugs. B. Ensures affordability of drugs. C. Ensures availability of drugs. D. Generates major revenue for governments. What does it? D. Yes. And drug revolving fund is not there to make for money making. It's not there for revenue. That's why they keep plowing back and whatever comes out of the back to purchasing more drugs, more medicine, because it's not meant for profit or revenue. So it promotes access to drugs. Yes, it makes it available at the same time affordable, because the cost is the profit margin is always small, because they want it to be affordable to the world patient. So the answer is D. 25 says all the following challenge drug revolving fund operator in Nigeria, except A. Insufficient financial resources. B. Barrier access for very poor and vulnerable. D. Availability of good central medical stock. A. Insufficient financial resources. B. Barrier to access to the very poor and vulnerable. C. Undue political interference. D. Availability of central medical stock. What's the answer?
C.
D. Availability of good medical. Availability of good medical stock helps it. It's not a challenge, right? It's a plus to it. But others challenge it. Insufficient financial resources is a challenge. Undue political interference is a challenge. Barrier to access for or the very poor and vulnerable is also a what? A challenge. So the answer is D. Mark. So we've come to the end of Bdt question 4 review. Do you have any question here? Please call. As usual, we multiply by 4. I will, as I said before now, I will collate.
So what is the number 1?
Okay, yes. Do that right now. 1 is D. 2 is C. 3 is C. 4 is B. 5 is B. 6A. 7 B. 7 B. 8 is A. 9 is C. 10 is C. 11 is A. 12 is B. Alright, so any other question? Any other question? Alright, so thank you very much. We are done with what is it called? The third question now. So before you go, I'll give you that of the fifth question, question 5. So you should solve tomorrow. We'll mark it tomorrow. We review that one tomorrow. I'll give you that of question 5 now. You solve tomorrow. We review it. No, yes, I have the record. So write your name, your full name on it.
But we marked the AUM yesterday. We later marked it yesterday.
AUM?
Yeah, we did AUM yesterday now. Or was it
Yeah, I compared with AUM that it was marked yesterday before we now do that of them. So, this yes. Do it now. Tomorrow, now. Once it's 9 a.m. tomorrow, we'll start. We'll work on that. 9 a.m. tomorrow doors. Once it's 9, we'll start. You're not waiting for anybody. Alright, thank you very much. God bless you.